Hello, in this example, we will see how to find the longest palindromic substring in an input string and build the solution in JavaScript and also compute the time complexity and space complexity of the solution that we will be building in JavaScript. Let's first try to understand the problem statement before jumping into the solution aspect of it. Let's say you have an input string S that reads something like BABAD. We have to find the longest palindromic substring within this entire string and return it. Now, what do we mean by a palindromic string? Let's say we have an example string called as wow. If you read the string from this direction to this direction, it reads as wow. Now, if you read the same string from the backward direction, it also reads as wow. So both directions it reads the same. That's what we mean by a palindrome. So this is a palindrome. Now in this string that we have, you can see BAB. If you read it in this direction, it's BAB. If you read it in this direction, then also it's BAB. So this is a palindromic substring, and as far as we can see, now after B there is A. So if you read BABA, it is not same as ABAB. So that is not a palindrome. That's why the palindrome ends here with BAB, because you read it in any direction, it reads the same. Now to solve this, we will be using expand from center approach. So we will have a center. Let's say this is our center, and from this center we will expand in the left direction and the right direction. Now one thing to note here is the length of this palindrome is 1, 2, 3. So that is 3, which is odd number, and we have another example here that reads CBBD. The length of this palindrome is 2. So if say BB in this direction is same as BB in this direction, it reads the same, and this is even. Now the thing to notice here is in this one you have one center, which is this one, and then it grows outwards. So an odd string will only have one center growing outwards towards the left boundary and the right boundary, that is expanding. And for an even palindromic string, you will have two centers which are adjacent to one another, and then they will expand outwards as needed. So that's the whole concept which we will be building our solution upon. So let's jump into the solution aspect of it. Let's say we have this input string BAB as our input, and let's say you have this as the center. Let's call it I. Now also there is other parts of the string, but let's just focus on this aspect for now, because we know this is the palindromic substring, and let's try to build our solution around this example. If this is I, the right boundary is I plus 1, which is this one, and the left boundary is I minus 1. I will keep expanding as long as I find the left boundary value. Let's say it's B in this case, and I plus 1, that is the right boundary element, which is also B, they have to be equal. So I'm able to say that this is a palindrome because the left boundary element, which is B, is same as the right boundary element. So as long as this stays true throughout the palindromic substring, as you go outwards from the center, which is this one, you can say that it's a palindromic string, and we can consider the border boundaries as the boundaries of our palindrome. So that's the concept we will build around, and this will translate into code something like this. What we are going to do is, basically in this example, just first explore the odd part and then also build the even logic, the even palindrome logic, and that's going to be pretty much how we're going to be proceeding with the flow of this video. We said that we need to return a substring, so we need to return BAB from the main string that we receive. So in the end, we're going to return a substring with some values. So substring like from one end to the other end, that's what we're going to be returning. And to do that, we will need two values here, as you can see. So we need a value here that is going to be the left pointer, which is going to be inclusive because we're using the substring function, and this is going to be excluding the upper element that we provide on the right boundary. So to pass these two values, let me keep a track via variable. Let's say we initialize it to 0, 1, and then we will modify it throughout the logic of our functionality. And we said that we will be trying to find palindromes. So I will build a child function within this function. Let's say get palindrome, and what this will do is it will take two boundaries. So I saw here that if this is my I have on the left boundary I minus 1, and on the right boundary I have I plus 1. So I will pass these two boundaries to my get palindrome function, and I will keep expounding outwards as long as this element is equal to this element. Otherwise I will just break the loop, and then I will return whatever boundaries I am left with. That will translate into something like this: left comma right, the two boundaries which I mentioned, and while the left boundary is greater than equal to 0, what this means is I said I will expand. Now as I keep expanding on the left side, this was I minus 1. So if it goes beyond this, there is nothing here, it's like this is 0, 1, 2, 3, 4 in terms of the position in the string. So if you reach less than 0, there is nothing. So we will say it has to be greater than or equal to 0, and the right boundary which we mentioned, the right boundary, and this is the left boundary. Right boundary will go in the right direction towards the end up to here. So we have to also put a validation check on that side to not overflow the bounds. So we can just say right is less than s dot length. So until we are within the bounds of the input string that we have, we will keep doing the logic aspect of it. And the logic aspect I mentioned is that I will keep expanding. So expanding from center. What that means is whatever center I have, in this case it was 2, I will go in both directions outwards. Now in terms of code, that will just translate to something like left minus minus and right plus plus. So go in both directions. So keep going in plus for this one, going in minus for this one, spread in both the directions, and at the end we are going to just return our left and right bounds. And right, I'm doing left plus 1 because the left is going to be inclusive and the right is exclusive in the substring. So we will do left plus 1 because of that. And what we will do here is, we also said at the start that as long as this I minus 1 element, which is I minus 1 is B and I plus 1 is also B in this case. As long as this stays true, we keep doing this. Otherwise, we stop. So if S of left is not equal to S of right, then we just break the loop. Because we put a loop here, we will just break out from the loop, and otherwise we will just expand, and then at the end, after we break from the loop, we will just return these two values. So this is going to be a get palindrome function. It will be a small palindrome, it might be a big palindrome. This doesn't care about whether it's the longest palindrome or not. Now to build the longest palindrome part, then we come to the next aspect of it. To find the palindromic string, we have to traverse throughout the length of the input string S that we received. So we will have to go from this end up to this end to see if you have the longest substring. You cannot just go midway and say, hey, this is the longest. No, you have to go all the way, and that will be of time complexity big O of n. And to do that, I will just use a loop, and I will go up till the length of my input string, and I will say here odd. First, let's just deal with the odd part, and then we will also build the even part. So this is for the even, and this one is the odd example that we looked at. So for odd, I will just call this get palindrome function, and for odd we will just have one center. Because we will just have one center, I can just give the left boundary and the right boundary for it. So I will say I minus 1 and I plus 1 to this function. Then I will say current max is going to be odd, because for now we just have odd. And then I also have a tracker here that will be my highest palindromic substring. So this will go in time complexity of big O of n throughout the length of the string, and for each palindrome that we try to find, this can have worst case time complexity of big O of n also, this one, because we keep expanding. So we can in worst case expand towards both ends of the input string that we receive. So the time complexity of this one will also be big O of n. And what we will do is, we will say final max is, now we have two values in the input array. Let's say, so this had 0, 1, and this will also give us two values, x and y. So to find which is the higher one, I need the one with the highest length, and that length is the difference between the two boundaries that we have. So the right boundary and the left boundary, and that will translate into something like this: current max of 1 minus current max of 0. I will compare with my existing final max of 1 and final max of 0. I will compare these two values, and if this is greater, I will say my current max is my final max. Otherwise, my final max stays as it is. No changes in the final max otherwise. And at the end, I'm just going to return my substring that we have here. And now time to say what this question mark is. So this question mark is basically from this bound, the left bound, to the right bound that we are going to be returning. And as we move through this loop, we will find the palindrome with a single center, because right now we just focus on the odd aspect of it, and that will translate into code something like this, Now we will also take care of the even aspect. Now, as you can see, the even string, this is a center and this is also a center. So there are two centers, and because of that, what we will do is even is we will call this get palindrome function, and this is going to be I minus 1 comma I. So because we will be having two centers, so this has one center for odd, and for even it will be two centers. So the left boundary, so let's say this is our left boundary and this is our right boundary if I is here, and this is I minus 1. So these are two adjacent centers that we have, and we will pass these centers, and from both the centers then we will go outwards. That's why we said I minus 1 up to I. And for the other one, because there was just one center, from that center we went outwards. That's why this approach is called outward from center. We expand from the center. And now before we just had odd, now we also had even. So now odd of 1 minus odd of 0, we will compare with even of 1 and even of 0. If this is higher, it is odd, otherwise it is even. The current max, I mean to say. And that's pretty much it in terms of building the logic part of it. And yeah, that basically builds a solution. And then in terms of the time complexity, this is already big of n complexity, and then within that we are also calling this get palindrome, which is also big of n, because worst case it can be going through the extreme ends of the input string that we receive, keep expanding towards the end. That's why the time complexity, the overall time complexity, will be bigger of n square. And in terms of space complexity, it will be big of 1, because we just use this counter here, and then we have another counter here which is also big of 1. So big of 1 and then big of 1, and then we're just updating the counters. We are not using any more memory than that, and because of that the space complexity will just be order of 1. And that's pretty much the solution. I hope you like the video. Please like and subscribe. Thank you.